Welcome to the first video in a series that will go over each of the topics in all 9 units of the AP Environmental Science curriculum. These videos will serve a couple main purposes. First, if you happen to miss the live lecture, you can watch its video on your own time. And second, you'll be able to use them to review the concepts in each of the topics. Some of these videos will include a single topic, while others, like this one, will have more than one. Multiple topics are linked together if they're short, related to each other, or both. In this video, we're going to be exploring topics 1.1 through 1.3, Introduction to Ecosystems, Terrestrial Biomes, and Aquatic Biomes. Even with the most basic observations of life on Earth, it's really easy to recognize that where living things are found, and the non-living resources that are also found in those habitats, are not distributed uniformly across the globe. We can easily see the Earth's biosphere is a combination of a variety of different habitats, both on land, in fresh and salt water, each containing very different conditions and resources. Because there are different kinds of non-living factors, that influences what kinds of organisms can survive in each of those habitats. Terrestrial biomes are those that are on land, covering a large area, and generally have a collection of communities that are present within each of those biomes. Terrestrial biomes are primarily classified by what kinds of climate conditions are present, most notably precipitation and temperature. Here is an example of how a desert would be classified, based on those two variables. We can see along the horizontal axis the duration of an entire year. On the left axis, we see the precipitation that a desert receives, and each of the bars along the bottom indicating how much precipitation in the desert received per month. The red line utilizes the vertical axis to represent how temperature changes in a desert over the course of an entire year. We can compare annual precipitation and temperature changes in a desert to another biome, like a tropical rainforest. In comparing these two biomes, we can see that deserts vary greatly in their temperature, whereas tropical rainforests remain relatively consistent. Another comparison can be made to the precipitation differences, as tropical rainforests have significantly more precipitation than a desert does. The reason why temperature and precipitation are such important variables is because those conditions determine what kinds of plants can survive in their habitat. For example, in order to survive in an arid environment like a desert, plants are going to need adaptations that allow them to do so. Cacti are well adapted because of their ability to store large quantities of water and protect that water with their spines. In a tropical rainforest, we find plants that don't have those same kinds of adaptations because water is far more abundant. Not only that, but we tend to find a greater quantity and variety of plants in tropical rainforests because of that abundance of moisture. Once a plant community is established in a particular habitat, it's those plants that, in turn, support the herbivores and ultimately omnivores and carnivores. Not only do plants have adaptations to allow them to survive in those conditions, but the animals do as well. Since temperature and precipitation are so important in determining what kinds of plants, and therefore animals, can survive in a given area, what is it that influences temperature and precipitation? To begin with, the most important factor in influencing temperature and precipitation is the sun. From the equator, if we travel north or south, the availability of solar radiation changes more substantially throughout the year as the Earth travels around the sun. Because of the angle at which the Earth spins on its axis, during certain times of the year, the sun's rays are striking the surface of the Earth at varying angles. For example, in the northern hemisphere, in the winter, the sun's rays are striking the Earth at an oblique angle. This means that the sun's energy is distributed over a much larger surface area and temperatures are cooler. On the other hand, 6 months later, the northern hemisphere is tilted toward the sun and the sun's rays are striking at an angle closer to perpendicular. This means that the sun's energy is distributed over a much smaller area, resulting in increased temperatures. If we were to look at a tropical rainforest, recall from earlier that tropical rainforests experience very little variation in temperatures throughout the year. The reason for this is because tropical rainforests are generally located close to and around the equator. The equator, which has pretty consistent solar energy throughout the entire year. But if we look at an area that's much farther away from the equator, like Seattle, we see that the temperature variation is much greater. In our winter months, when the sun's rays are striking the Seattle area at a much greater angle, the temperature is cooler. But in the summertime, because the sun's rays are striking the Earth's surface closer to perpendicular, the temperature is greater. Understanding this helps to explain why different types of biomes are generally distributed based on latitude, which runs east and west around the globe. The tropics, with the most consistent solar radiation, are clustered around the equator and have a great variety of plants and animals because of that consistent energy from the sun. As we look at biomes north and south of the tropics, we can identify relatively consistent patterns. Just north or south of the tropics, we tend to find desert. North or south of that, we tend to find temperate regions. And then north of that, we find biomes like tundra and taiga, also known as boreal forest. As a side note, you may notice that I reference tundra and taiga as just being in the northern hemisphere, and that can be explained by the fact that more of the Earth's land area is present in the northern hemisphere than in the southern. Now that we have a good understanding of how the sun influences temperature and precipitation, which in turn influences plants and animals, we can now quantify and classify biomes. This illustration here allows us to make comparisons between different kinds of biomes. On the y-axis, we can see the annual average temperature, and the x-axis has the annual average precipitation. If you look at desert, you will see a couple of things. One is that it has a very low annual precipitation and that there is very little variation in that precipitation. Compare that to taiga. This kind of biome has much more substantial variation in precipitation throughout the year. We can also compare temperature differences between different biomes. The tundra biome experiences very little temperature variation throughout the year, perhaps 7 or 8 degrees Celsius, but a grassland biome can vary as much as 35 degrees Celsius. A variety of other factors also influence biodiversity and biome distribution. One of those factors is the presence of fresh water. Throughout history of human settlements, people have generally put down roots where they had easy access to fresh water. Streams, lakes, and rivers were common areas for people to establish new settlements. Thanks to things like topography, climate, and latitude, fresh water on Earth's surface is limited to areas such as lakes, rivers, and streams. These two maps illustrate where some of Earth's largest rivers and lakes can be found. Because fresh water is an important resource for agriculture as well as drinking purposes, its changing availability is of great concern. These data were collected in the early 2000s and illustrate places on Earth that have been showing a decrease in freshwater availability, the red and orange regions, as well as the locations showing an increase in freshwater availability, the blue areas. Another important habitat resource are forests. Not only are forests important ecologically, They are also a valuable economic resource, as lumber is one of the most common building materials. Like any other plant, trees require certain environmental conditions to allow them to grow and reproduce. In addition, the availability of fresh water, temperature, soil conditions, and elevation are all influential factors on whether or not trees can grow in a given area. Forests can be classified into one of three primary categories based on where they're found: tropical forests in the tropics around the equator, temperate forests primarily in the northern hemisphere just north of the tropics and deserts, and the taiga in a band around the globe in the northern hemisphere. In addition to providing habitat for animals and being an economic resource, forests and the trees that comprise them are also aesthetically valuable. This map illustrates the diversity of major tree types and where they're found in the world based on the environmental conditions that can support those species. Biomes on Earth are not limited to those found on land. Nearly 3/4 of Earth's surface is covered with water. Just like land-based biomes begin with a foundation of photosynthetic organisms, the same is true in aquatic biomes. However, unlike on land, a different set of abiotic factors influence the presence and type of photosynthetic organisms. The primary photosynthesizers that support aquatic biomes include algae, kelp, phytoplankton, and aquatic plants like Alodia and mangrove trees. Aquatic biomes are first classified based on whether or not they are freshwater or saltwater. Freshwater biomes are distinguished from marine biomes because they have very little or no salt content. Freshwater biomes make a tiny fraction of all water on Earth. In spite of this, they are a critical source of drinking water and water used for growing crops in agriculture. Freshwater biomes are further broken down into three groups. First up are lakes and ponds. These are bodies of non-moving water. Although there is no exact size requirement to distinguish a lake from a pond, lakes are generally the larger of the two. The second type of freshwater biome are rivers and streams. These are distinct because they're identified by a constant flow of water. This flow carries dissolved nutrients downstream, allowing for plants to thrive there. This illustration outlines some of the more important features of rivers and streams, like the headwaters, which is the source of flowing water, tributaries that are smaller streams feeding into the main river, and ultimately the mouth or delta, which is where the flow of water slows and begins to spread out as it reaches an ocean or lake. The final type of freshwater biome is actually a group called wetlands. The three main types of wetlands are bogs, swamps, and marshes. They're distinguished from one another by what kind of plant life is thriving there, if any. Saltwater, or marine biomes, include more area of the Earth than all terrestrial and freshwater biomes combined. Although marine biomes include coral reefs and intertidal zones, it's the open ocean that represents most of marine biomes. In any given unit of area of open ocean, we find very little photosynthetic activity, but summed up, because the ocean is so large, it contributes far more of Earth's photosynthetic productivity than nearly all other biomes. Taking the total area of the ocean into account, we see that it is responsible for 1/4 of all of Earth's photosynthetic productivity. As freshwater rivers and streams meet the ocean, this is where we tend to find water defined as brackish, not as salty as the ocean, but not considered fresh water. The types of plants and animals living in this kind of habitat are well adapted to tolerate the salinity present. Before we look at the kinds of resources found in aquatic habitats, coral reefs, because of their diversity, deserve special attention. Just like tropical rainforests on land, Coral reefs are the most biodiverse of all aquatic environments. Coral reefs are found almost exclusively within the tropics and are always not far from land, either large continental masses or island groupings. Coral reefs are extremely fragile, yet provide a number of benefits, including habitat for thousands of different kinds of organisms. They're also important in protecting coastlines from storm surges. They are an important source of food for millions of people. Ecotourism is becoming increasingly popular and provides employment opportunities. And finally, coral reefs are important in the development of new medicines. The animals and plants present in coral reefs are being studied to develop medicines useful in treating Alzheimer's disease, bacterial infections, heart disease, and cancer. Perhaps unsurprisingly, the most important resource obtained from aquatic environments is fish. Over 3 billion people on Earth rely on fish as their main protein source in their diet. For just over 1 in every 10 people, the fishing industry provides for their economic livelihood. But just as we saw with the distribution of fresh water and the distribution of forests on land, the distribution of fish isn't uniform. Different species require different conditions in order to survive and reproduce. Temperature, salt content, and dissolved minerals are 3 such important variables. Here are 4 examples of different kinds of tuna that are found in different oceans around the globe because of different habitat conditions. This map illustrates the quantity of fish that are harvested from the sea every year per square kilometer. With this map, we can identify a couple things. One tells us where the fishing yield is higher due to fish abundance, and the other identifies places where fishing is an important part of people's lives. In any biome on land or in water, because the necessary resources for survival are finite and distributed unevenly, species are forced to interact with one another to acquire what they need. Let's review some common species interactions. The first one on this list, neutralism, is one that many ecologists debate the true existence of. In neutralism, species A and species B exist in the same habitat, yet have absolutely no effect on one another. The reason why ecologists debate this is because it's difficult to say without question that one species has absolutely no effect on another. The second interaction is called mutualism. In mutualism, both species A and B benefit from each other's presence. An example of mutualism could include a flower and a bee. The bee benefits from the flower's presence because the flower provides nectar that the bee requires. The flower benefits because as the bee is obtaining that nectar, it picks up pollen from the flower and transfers it to another flower for reproduction. In commensalism, one species benefits while the other is neither helped nor harmed. A great example of commensalism is the presence of barnacles living on a whale's skin around its mouth and pectoral flippers. The barnacles benefit because of the habitat provided and because as the whale moves around looking for food, the barnacles take advantage of that food as well. The whale, on the other hand, suffers no loss and benefits from no gain by that interaction. Competition exists because resources in a habitat are limited and 2 species both require that resource. Competition results in a negative outcome for both species involved. The species that is outcompeted and therefore does not gain access to the resource is clearly a negative. But even the winning species still suffers a loss. That loss could be due to physical injury, but always involves a loss of energy and the one resource that can never be regained once it is passed by, time. Amensalism is an example of an interaction in which one species suffers no ill consequences or benefit while another is harmed. A great example of this can be demonstrated by a large animal stepping on a small insect. The large animal is very unlikely to suffer damage, But the small squished insect, that's clearly a negative interaction. Predation is likely the best known species interaction. It is the act of one organism, the predator, killing and consuming another organism, the prey. By that definition, an herbivore that is feeding on plant material is a predator and the plant, the prey. That particular form of predation is called herbivory. Finally, there is parasitism. Like predation, one species benefits and the other suffers a loss. But unlike predation, the parasite rarely kills its host, at least not too quickly. Another contrast between parasitism and predation is that parasitism, like these other two interactions, are forms of symbiosis where one species lives on or in another. Species that inhabit the same area tend to utilize different resources or the same resources at different times to avoid having to compete for them. The competitive exclusion principle says that if two species have the exact same requirements of their habitat, competition will result, with the losing species being rendered unable to survive in that habitat. Resource partitioning allows for different species to take advantage of different resources in their habitat, avoiding the need for competition. For example, perhaps two different species of bird eat the same kinds of seeds that a plant produces. One species may go after the smaller seeds, while another one goes after the larger seeds. Another form of resource partitioning can be seen in how species occupy a habitat. One species of bird may prefer nesting sites that are high up in a tree, whereas others may prefer nesting sites closer to the ground. This illustration demonstrates how a variety of species can all coexist because they're utilizing different food sources at different locations. The look and position of Earth's biomes today isn't how it's always been. Throughout geologic time, over millions of years, the composition and distribution of biomes have changed. About 250 million years ago, nearly all of Earth's land masses were collected into one supercontinent called Pangaea. But thanks to plate tectonics, the continents have shifted from that position. That shift affects what kinds of environmental conditions are present in a given area. Extinctions and naturally occurring climate change also play roles in the makeup of biomes. It probably goes without saying, but in much more recent history, within the last few centuries, we have had a substantial impact and very likely detrimental impact on Earth's habitats. We divert the flow of fresh water so that we can irrigate our croplands and protect our cities. We also deforest large areas of land for the purpose of harvesting lumber and creating grazing land for livestock. And we also break up large habitats into smaller sections with roads and housing developments. All of these activities decrease the available space for other organisms as there is less available area to support life. That concludes this video on topics 1.1, 1.2, and 1.3. Thanks for watching. Until next time, take care.